Hey everybody, hi everyone. It's Brian with HighRes. Do want to thank everyone for joining the webinar today on the simplification of requesting, ordering, and managing your sample library. Melissa and the HighRes team are excited for today's event and welcome your participation. Now, during today's session, you will be able to submit questions through the Q&A tool in live event. We will, as a group, review those questions and we will address them following Melissa's presentation. And on that, I'd like to introduce to everyone today Melissa Bennion. As you can see her here. Melissa Bennion is a scientist within the bioassay and high throughput screening team at Biogen. She focuses on internal and external phenotypic efforts, including assay development, validation, and execution of HTS assays. In addition, Melissa and the team work on implementing automated processes to increase sample throughput and developing HTS infrastructure for data analysis. Today, Melissa will introduce you to software tools that Biogen uses to streamline its sample management workflows to better support its internal and external customers. And on that, without further ado, ladies and gentlemen, Melissa Bennion.
Thank you for that introduction, Brian, and welcome to the Biogen HTS Lab. I'm excited to be here today to share the fabulous tool that we have developed with HighRes and Sigillion for managing our compound workflows. It has been a game changer for our organization. So a few years ago, we were looking hard at the way we were handling our compounds. I'm going to liken our workflows at the time to the old bird trail located in southern Utah from where I'm from. My father's idea of fun was terrifying us by traversing this narrow, precipitous dirt path. The journey was slow and wrought with potential hazard. Likewise, the sample management workflows at Biogen at the time were slow, expensive, and packed with risk. So we were paying a CRO to do most of our compound management work, which was expensive. For large cherry picking orders, we were experiencing turnaround times of 4 to 6 weeks. We were needlessly using high volumes of compound to do serial dilution, which was rapidly depleting our library. Our sample tracking was manual, which is very dangerous. And there was no consistent way for chemists to communicate with the assay scientists and vice versa. We knew the rickety old trail that we were on was not going to beat the competition. So we sought for a faster and safer and more efficient road. What we developed is an automated sample management system that we call Cobb Store. It is a combination of Sigillion sample management software and HighRes ordering and automation software. So now we can do a majority of our compound management workflows internally, which is saving us a lot of money. Our turnaround time for large cherry picking orders has been reduced from several weeks to just a couple of days. And by instituting the ECHO, we have reduced the amount of sample waste by at least 40-fold. We now have a sample tracking system which significantly reduces the effort for scientists and removes a lot of error. And we have a system to efficiently communicate across our project teams. So our solution was to use our existing robots that we already had in-house. Many of you are familiar with this hardware. At the heart of the system, oh, I forgot to get my pointer out. At the heart of the system is the LabSite Echo, which we use for compound transfers. We have the AmbiStore, which is a storage device for our compound library plates and our destination assay plates. This AmbiStore here has 336 positions, and it can be filled with either 384 or 1536 well plates. Also on the system, there is a X-Peel for peeling seals off of plates and a plate lock for sealing plates. And then tucked away on this shelf is a Combi NL, and that is used for backfilling DMSO to balance the concentration or the volume of DMSO in every plate on the in the destination plates. On this bottom shelf, there is a HighRes microspin This is a centrifuge we use to spin down the compound plates before we do the transfers on the echo. And then we have this robotic arm, the A cell, is used for trafficking the plates across the system. So the power of our system lies in the software. So here's a schema of the Cobb store system. Now, it looks complicated, but don't worry. I'm going to give you a demonstration of the system. But just as an overview, there are 4 pieces of software, 2 pieces from Sigillion and 2 pieces from HighRes. The first piece is called Sigillion Request. This is the software used for placing compound requests. So this is where the chemists go in and place their orders. The next piece of software is Sigillion Store. This is the sample inventory. And after that is HighRes Solario Order Broker, or Cobb. This is the software used for placing orders for automated runs. And then there is HighRes Solario. And that, as you probably are aware, is the automation software. So unfortunately, I cannot start the demonstration in Sigillion Request because it contains proprietary information to Biogen, such as our project names and our targets. But this is a software where the chemists go in to request the compounds that they have made and they want tested in specific assays run by the DMPK, SAR, or the HTS groups. So after the chemists make their request for these compounds to be tested, the assay scientists go in and pick up those orders and push them into store. And I'm going to pick up the demonstration in store. So I'm going to move to our software. So this is a landing page for Sigillion Store. So on this page, so I want to introduce you to a lot of the features inside of Store before I go ahead and place a compound request in Store. So in this hamburger menu, so there are a couple of things we need to set up prior to making a request, a compound request. These are things that are done one time and then they're there for future use. So one of those things is you need to have your containers populated into the software. So today we'll be using the lab site LP0200 plates, which many of you know is the low dev volume 384 well plate. So that has been entered into the system. And also we'll be using for our destination plate or assay plate, this Corning 3575 plate. And so likewise, that has been entered into the system. Another thing that we will need to place an order is a compound layout. So how we want the compounds to be placed on the plate in the order. So today we're going to use this layout right here. It's 384 well plate. We're going to put 32 samples on it with 10-point dose response. Okay, so as you can see, the compounds are going to be placed in columns 3 through 22. And what we have here is the top ordinal in each box is the sample number, and the bottom ordinal is the step in the dose response. So there are going to be 10 doses for each sample and 32 samples per plate. So you can when we're placing the orders, you can submit however many samples you want, 600, 3, whatever, but they'll just be filled into each plate according to this map. Now you'll notice that columns 1 and 2 and 23 and 24 are open. We will go in and add controls into these wells. We are testing this feature right now, and so it's not in our production environment, which I'm doing the demo in, but we do have the ability to add controls to our plates and also standards. Okay, so what I'm going to do now is demonstrate how to make a compound request inside of request. So I'm going up to the create request button, and there's several different types of requests we can plate. Today we're going to do the liquid sample request. This is selected when you want to cherry pick compounds across your entire collection of plates. Other examples are the solid sample request. We don't do that here because we don't have any solids at our site. They're at our CRO. There's also the container stamp request. This is when you want to test every sample on a certain container. We use this when we're doing our HTS screening. But let me go ahead and demonstrate this liquid sample request. Okay, so what I'm going to do now is just fill out this form. So the output container type is my destination plate that I just showed you, this Corning 3575. And I'm going to select the layout that I just showed you as well. It's that 384 well plate with 32 samples and 10 doses. And there are two ways to bring in the samples that you want to test or that you want to request. One is using this plus sign to bring them in one by one, or you can upload a file. If you're going to bring them in one by one, you can fill out these fields right here that will auto-populate the concentration and the volume that you want. But I'm going to use the feature for bringing in a file. So I'm just going to say what date we want this done and make a note what system that I'm going to run this on and a little description. And I'm going to go find the file and bring it in. Okay, so let me just walk you through each of the columns. In the first column is the bio ID, and then we have concentration, dilution factor, amount, destination slot, and the number of copies of the plate we want. Now, the real power of Store is that I have, it is completely flexible. I have absolute power on what I want to test. So let's say, for example, that I know this compound here is really potent. And so I don't want to start it at 10 millimolar, I want to start it at 1. And maybe this compound is, you know, kind of potent too, so I'm going to start that at 5. Likewise, you can customize the dilution factor you want. Maybe you want this one to be 1 to 3 and this one 1 to 2. You can choose the volume. You can also determine which slot on the plate you want to test. Maybe you don't want this one to be on an edge well, so you can swap it with another one. You can also choose how many copies of the plate you want. This one applies to the whole order. But as you can see, this file that I brought in has multiple dilution factors, and you can start your concentration wherever you want. They can all be the same, they can be different. It's completely flexible and customizable. Okay, so we are ready to submit this order. So I'm going to click submit here. And what's going to happen is it's going to assign a request number. So we're going to follow request 829 through the system. Okay, what I'm going to do now is I'm going to change my hat. I'm no longer the assay scientist ordering the compounds. I'm now the sample manager. So the sample manager goes in and looks at what kind of work is lined up for today. And so I'm going to select this request 829, which we just made, and accept it. And what I'm going to do as a sample manager is I'm going to make a selection of where I want these compounds to be sourced from our library. So some compounds are represented across the library multiple times in different plates. So this is just going through the selection strategy. So right now, all of our compounds are in these LabSci LP0200 plates. They could also be in, we're moving to 1536. So when that happens, we'll have that available as an option as well. And then you say which sample you want by choosing one of these options here. I'm going to say, please choose the samples from the newest container first and accept that. And then my request moves over to the accepted queue. And what I'm going to do is schedule it to be run on the system. So, or to move over to Cobb. So click the number and say schedule. We want it done immediately. Now it's in the schedule tab. And what I'm going to do here is just pick the order and push it over into Cobb. So now it is being pushed to Cobb. So I'm going to leave the Sigillian software and move over to high-res software. So some of you are familiar with the high-res software and know that you work through the tabs from left to right. So I'm going to start in the order tab. And what we're doing is we're just waiting for our job we just made to be pushed from store into Cobb. So normally it takes a couple of minutes, but I can hurry it along by saying get new orders or push this refresh button, and it will look for that order to be brought over. So that might just take a second. Here it is. Okay, so we have request number 829. I'm going to select that. And at this point, I'm going to click this Assign Labware button. And when I do that, it's going to tell me where it's going to look for the samples in my storage devices on the system. Now, we had kind of a early morning change of which system I am doing this demonstration on for unforeseen reasons. So it's not just an AmbiStore as a storage unit. The system that I'm giving this demo on also has a SteriStore, which is a incubator. So it looks a little bit, that shows up as an option. But basically, all that's happening here is the system is telling you where it's going to look for samples. So the compound library is always on the system and in the AmbiStore, and it's going to look for it there. The intermediate plate and the DMSO plate and the destination plates are plates that we need to load on the system, and we can load them in these locations. We can modify these locations if we want to. The intermediate plate is used for diluting the compound further for that 10-point dose response, and the DMSO plate is used for doing backfills of DMSO to balance the DMSO across the plate. So I'm going to go ahead and submit this order, and it's going to get pushed from the work available screen down to work invalidation. So the only thing that has to be done to validate this is you simply click the scan and validate button, and the barcode scanner on the outside of the AmbiStore, or the SteriStore in this case, goes and scans all of the barcodes in that storage device, so it knows where the compound plates are located and the destination plates and intermediate plates and so forth. I'm actually not going to run this because, I mean, it takes like 2 minutes to scan the devices, but I'm not actually going to run this today because we have limited time. So I'm just going to force validate that. And now the job disappears and moves over to the system overview tab. And we can see it's now one of the Solario runs on the system. So here it is, 829 and submitted. So now it's left Cobb and entered the Solario world. So I'm going to open Solario. And so the really great thing about Cobb is that it does all of the heavy lifting. So for you Solario users out there, you know that normally you start in the design tab and work through the order tab and the analyze tab. But Cobb takes care of all of these, and the only thing you really have to do is kick off the run. But for the purpose of today's demonstration, I'm just going to show you what it looks like so you can better appreciate all the work that you don't have to do. So I'm going to start in the design tab. So what we have here is a master protocol. And master protocols help reduce the number of protocols in our protocol library. So the data imported into Solario will determine which threads within the protocol will be used, thus providing a data-driven environment. For example, in store, you can select any number of compounds, any number of starting concentrations, as many dilution factors as you want, and you can have as many copies of the plate, and you can have controls and standards. In this master protocol, there is a thread for each plate type, and etc. And it is activated or deactivated depending on the orders brought through by Solario. So here is the source thread and all the steps involved for all those compound plates. Here's the thread for intermediate plates, for those dilution plates. There are 4 threads for destination plates. So one thread would be for each copy. If you want more than 4 copies, then everything runs through one single thread. So you could have 10 copies, no problem. The control, there's a thread for control plates, standard plates, and these DMSO backfill plates. So this is all the work you don't have to do. It's all there, already done. In the order tab, normally what you do is you go in and assign positions for all the plates to be used in the run, but this was done by Cobb. So you can just go in and confirm that your plates are where you would expect them to be when it validates that when it goes through and does that scan during that validation step in Cobb. Okay, the analyze thread is pretty cool. So what you do here is you select the order that you would like to simulate, and it will, oops, dang, of course that happens. Anyway, what it does is it simulates the run and gives you a line for a row for each plate that will be processed in the system. So, and then it gives an indication of like when each move is going to happen on the system. So when the liquid transfers, etc. So it's nice to look at this just to see like about how long the run's going to take. So this will take about an hour, and make sure that everything looks good. But really the only thing you have to do is come in as the robot operator and start the run. So to do this, you'll notice all of the instrumentation is in this left panel, and this is a bigger system than the one that I showed in the picture. So there's a lot of instruments there, but basically you just push the start button and everything connects and initializes. And once it's initialized, it turns green and it's ready to go. So we're just going to wait for the system to wake up and get moving. Okay, some of these take a little bit. Okay, so once everything's green, you select our run, which is number 829, and you simply push start run. And at that point, a pre-run checklist pops up. And so this is the point where you just make sure that the system is absolutely ready to run. So it's just asking you, did you put a counterbalance in the microspin? Is there DMSO primed on the combi for making those intermediate plates or doing backfills? Is there sufficient peel and seal on the X-peel and the plate lock? Is the echo ready to go? Are all the nests cleared? And then you can tell the system how you want the destination plates to be handled. Do they have lids on them? Do you want the plate sealed at the end, etc.? And then you push continue and the run starts. So sometimes I run really big runs that go for a couple of days. And what's great is that as these plates are being produced, everything is being updated at that same time in store. And then at the completion of the run, everything is reported to store. So I'm going to jump back over to store now and take a look at, I'm not actually going to process it on the robot because we don't have time, but I'm going to show you a previous run to see what the outputs look like in store. So I'm going to go to the completed queue, and I'm going to jump to one that is interesting to look at. Let's see, this one will do. Okay, so a couple of things that you can do when you're looking at the run is, first of all, you can use this export function to export. I don't do this until the run is all the way completed, but you can have an export of this file that you can take into your data analysis software. So you can export that, it pops up, and then you can take that file and run over to your data analysis software and load that in, so you don't have to do any manual mapping. Another thing that you can do is view sample logistics, and I'm just going to jump to this last Outputs tab to show you what it reports. So here is the source barcode. This is the compound plate and which well. And this is the compound that it pulled from that well. And this is the volume that was placed into the destination plate, so 300 nanoliters. And then how much it was diluted by, so 0. The next row is the same compound, only 150 nanoliters are brought over, and then it's diluted with 150 nanoliters. So then it gives the target concentration. So you can see the dilution series across the this particular compound, and the final volume is balanced with DMSO. And then it gives the output location. So this went to well A3 of this particular plate. So everything is there in store. So if I could show you request, what I would show you next is that all of this is also reported back to request, so that the chemists know that these plates have been generated and that the assay scientist is now in the process of testing these samples. So, okay, that completes the demonstration. I just want to summarize by saying that we've developed an efficient compound ordering system with automated workflows. We now have universal workflows across our HTS, DMPK, and SAR groups with very high standards and a lot of confidence in the system. We have an efficient end-to-end tool for sample tracking. So compounds are in our inventory. We don't have to hunt for them. We just do a scan of the barcodes across the system, and they're easily found. The export maps are easily uploaded from store into our data processing systems. So there's no more manual steps in tracking our samples. The system is very simple to use. All of the calculations for the dilution series, or if you want any of the compounds diluted, are done in COB. That's not on the assay scientist or the robotics folks to figure that out. All of the methods are created in COB, and so the robot operator doesn't have to do that either, and all of the orders are created in COB. All of the heavy lifting of operating the robot is completely taken out. And in fact, we have our assay scientists running the robots. We don't have an engineer on staff at Biogen, so that is key for us. The system is very flexible, as I demonstrated in store. You can start your compounds at any concentration you want, any dilution factor. You can position them anywhere on the plate that you want. You can have any number of inter and intra-well replicates. It's all very simple and flexible for setting up. We have a system that preserves our compound library, where we've now reduced the amount of compound we are ordering by 40-fold, which is huge. And we have an effective system for communicating across our project teams. So there's no more chasing down emails, or there's one centralized location for all members of the project team to go and order their compounds and have them processed, and everybody is visible to that. So our system is faster, it has minimal waste, it's less expensive, and we've drastically reduced our errors. So I just want to finish up by thanking all of the many people that made this possible. At Biogen, we've had support from our RDIT group, particularly Pravin and Rhonda and Stephanie have done a great job in supporting us, getting this up and running. On the high-res side, we had great commissioners. We've now installed this on 2 of our systems, and we'll install it on 2 more this month. So Joe, Agresta, and Tanuj helped us with that. And Brian and Lisa have helped with the development of the of COB. And on the Sigillian team, I'd like to thank Jerry for all this help with integrating with Request, And Franz and Etienne and Kwai have been really awesome in making sure that all of our requirements have been met for implementing this tool. So with that, I'd like to turn it back to Brian, and maybe we can open up for some questions.
Thanks, Melissa. Thank you for that presentation. Very informative. Awesome. We do have multiple questions, so let's dive in. So first question is Sigillion an internal inventory software? Do you want to give a description of the Sigillion software?
Yes. So yes. So that is our internal inventory of compounds. So the software has two pieces, as I said. So request is a place where you can go in and you can type in your samples, enter a list of samples, and you can see the inventory, how much of each sample is available, at what location, in which plates, etc. And in Sigillion Store, that is where the samples are like located electronically, like in the database. That's the database of our samples. So what I didn't include in the demonstration is, I thought about is to show you how to bring new samples into that inventory. And we're routinely doing that as we add to our compound library and as our chemists submit new compounds for testing for our different projects. I hope that answers your question.
I'll wait for them to reply.
Okay.
Second question we have is how and who creates the master protocol in Solaria?
Okay, that's a good question. The master protocol is created by the high-res team, and I believe it's not, there are a couple of things they modified for us, but we're not the first ones to use it. I know that they've worked with other companies to on this master protocol, so they just tweaked it a little bit for our group. So that's not on the Biogen team at all. That just kind of came with the COB package.
Next question. Does COB allow for more than one intermediate plate?
Yes. So it depends on what you order, but COB does all the assignments. So on big orders of, maybe 1,000 or a couple of hundred of compounds, there will be multiple intermediate plates. That is all calculated by COB. You don't have to figure that out at all. But yeah, you can have, it often has multiple intermediate plates.
Cool. We have a lot of questions, so.
Okay.
All right, next one is, how is the interface for creating layouts? For example, how easy is it to do a 1536 layout in Sigillion? Oh,
that's a good question. It's actually very easy, and I would demonstrate it, but it's a very easy tool. You just select, you can select multiple wells and right click and assign like a sample ordinal and a dilution factor to it. You can copy and paste. I would say it takes, 2 or 3 minutes to set up a plate layout, maybe up to 5 for a 1536 plate, but it's, it's pretty straightforward and it's not a big deal. We just tried to limit the number of layouts we have for simplicity across the system, but from time to time I'll add a new layout. It just takes a couple minutes.
Someone else has a question of, do you only have 300 nanoliters of compound in the LP200 plate?
Oh, okay. So what the 300 nanoliters is that was what was transferred into the destination plate. The LP200 plate, as you know, you can have up to, I think, 12 microliters in that. And so I think we usually have about 10 microliters in that. And then every time, I'm glad you brought this up. Every time, I forgot to point this out in the demo, every time that something is removed from that source plate, some compound is removed from it, it's reported back to the database what the new sample volume is. So let's say that you removed 300 nanoliters from 10 microliters, then it reports back that you now have 9.7 nanoliters in the well. The other thing is that, as you know, the ECHO does a survey before it does the transfer. And so that survey volume is populated back into the database. So you always have like the most recent snapshot of what is actually in the plate. And there's a tool in store where you can, if you're worried about plates getting low, you can ask it to show you how many plates have volume less than 2 microliters so that you can start replenishing these samples across your collection.
Cool. We have a couple more questions, and then we'll probably have to take the rest offline. We can address them. Okay, Melissa?
Okay.
But next question we have is, what about error recovery? Do you have to start from the beginning, or can you resume at any given point?
Oh, also a really good question. So it's just a typical Solario run once it gets into Solario, and I'd say 90% of the time that you can recover and just keep moving the job along. Like if you forgot to load enough peel or whatever, you don't have to start over. The only time that you have to start over is if there's a problem with a transfer on the ECHO and it lost the plate map for that, or like a survey sample fails. Then about half the time you can recover, about half the time you have to start over. But I'd say 90% of the time, error recovery is awesome, and it's just exactly the same as you would do for a normal Solario run.
Okay, I'm going to address one question someone brought up, and that is, sorry, I've go to published. Are request and store proprietary or commercial? Those two software packages are commercial. They are provided by Sigillion. If you have any questions on that, you are more than welcome to reach out to myself or John Mole from the invite, and we're happy to make introductions for you. Let's see here. Okay, so question is, how does order broker know where the plates are going to be in the AMBA store if you skip the inventory scan?
It won't. I only skipped the inventory scan because I knew I wasn't actually going to run it. In practice, you would do the inventory scan, and it's just a tool for skipping the inventory scan is just a tool used in testing, but you would never use that in practice.
Someone has a question, going back. And what would be the bottleneck in your process, both including software and hardware?
I think the bottleneck, that's a good question. I mean, I think it's just the robots running, you know, it just takes time for robots to run. So, but Cobb has kind of a cool tool where you can break runs. So maybe you submit a sample, a run that has like 3,000 samples that you want 10-point dose. Maybe that's going to take a couple of days to produce. You can either just run that and let it take a couple of days, or you can break it into smaller batches. So I think the bottleneck is just process time, but I mean, the process time isn't more than it would be outside of the system. It just takes time to run samples through robots.
Okay, next question. Sorry, just going through. Here's more of a overall process question. So this individual has multiple questions. It really pertains to how long was the implementation period? Like, how long did it take you to get to this point?
Okay, good question. So, I mean, we've now had the software in our lab for 1.5 years. I think it takes like 2 to 3 months. The high-res software has been in use for a long time. It's very stable. The Sigillian software is good, and the team acts fast to address any like enhancements you need or any situations that arise. So I would say, so actually, for example, we're having this installed on 2 more systems this month, and we have a month slated for that process. But maybe that's a little bit faster because we already have instances in the lab. So I would say a few months.
And all these is a final question. Again, we have probably 18 questions to get through. Actually, now 19. So what I would suggest is, just for sake of time, to all who are still attending, we will answer these questions. For those of you that have attended this session, we have the list. We will definitely send a follow-up with answers to all of your questions. So we don't get to them today. We'll definitely get to them, and we'll follow up with you later this week. I'd say the last question would be, is what happens if there is insufficient quantity of sample?
Oh, good question. So the first thing would happen is you wouldn't be able to place that request. It would notify you at the point where you're in the Sigillian store. It would say, making that initial request, it would tell you that there was insufficient sample, and then you could remove that compound from the order. Let's say that you have, at the time that you submitted the sample, there was enough volume, but then you didn't run it for a day or two, and somebody came in and scooped up one of the samples you were planning on using. At the point of the sample manager pushing that through the system, it would notify you that that sample is no longer available, and then you would have the option to remove that sample at that point. You can always backfill samples by plating them on a new plate and then loading them into the system. So yeah, that does happen.
Okay. And then we'll say the final question will be, sorry, Melissa, just get it up. How do you deal with evaporation issues with respect to assay ready plates?
So what we do is all of our plates are sealed. All of our assay ready plates are sealed at the end of making them. And then we move them offline and we vacuum seal them into plastic bags, and just, they're usually good for about a month at that point, at least. It depends on, you know, the sample, but we typically use those up within a month. I've made samples and shipped them to our contract labs overseas, and they haven't been tested for, you know, like a month at that point, and they've had no problems. That's a typical workflow for us.
Okay. Any other comments, Melissa? Anything you'd like to add in closing?
No, I just wish that I had more time to just like really do a deeper dive. If people want to reach out to me individually, I'd be happy to talk to them more. I'm a huge fan, and it's a great system, and it really just met all of the requirements that we were looking for in our dream system. So thank you to the Sigillian team and the high-res team for this fantastic solution.
Well, thank you, Melissa, for today. Really appreciate it. It was a great presentation, great demonstration. And we also wanted to thank everyone for attending. Really appreciate it. You do have a lot of questions still, so we have these recorded. We will connect with Melissa, and we will follow up with both the questions and the answers to all attendees. If there are any additional questions, you are more than welcome to reach out to myself, Brian O'Sullivan, or John Mole. You will find our emails on the invitation that was sent out yesterday. On that, Melissa, thanks a million. Really appreciate it.
Yeah, thank you, Brian.
I hope you all have a wonderful day. Bye.
All right.